Statistics is the language of data. So before diving into any fancy machine learning, you need to understand and describe data sets. To begin with, you need to understand your data. And in this video, I'll walk you through a few methods of how to do that, from going from the types of data to the measures of center, the measures of spread. This is essentially giving you the foundation that you will need to become a great data scientist. So let's begin with a big picture differentiation. Descriptive versus inferential statistics. So statistics gets very hard to say whenever you say it quite a lot, so I apologize. Descriptive statistics is about summarizing data you already have. It's using the mean, mode, median, standard deviation, the variance. It's essentially giving a number to your data so that you can describe it to other people. It's a descriptive statistic. Summary statistics is another name for it as well, so it summarizes your data set essentially. Again, mean, mode, median, standard deviation, variance. Those are pretty much the most important things in statistics. It all boils down to that. Then you've got your inferential statistics. So your inferential statistics stems from having a sample from your population. So you can have a sample, you can do your summary statistics there, you can use your descriptive statistics using the jargon. You can use your descriptive statistics, use that to infer things about the large scale population. So if you've got a set of a certain gender of people and they perform a certain way in a test, you can make an inference that those people, that gender performs a certain way in this test. Those tests have been done way back in the past. They tried to make a distinction between the intelligence between men and women, and I think what the studies show is that men tend to have a higher spatial acuity, whereas women are a lot better with words. Essentially, they can link. They've got the more linguistic side of things. But people will obviously debate whether or not that's a social thing, or if that's a it's a nature nurture thing, you know what I mean? So that's pretty cool. That's inferential statistics and descriptive statistics. That's probably the last time I'm ever going to mention that, because I don't really want to say it anymore because it's really hard to say for some reason, and also it's just definitions. It's okay, we can gloss over that. It's not really that important. Another thing, more definitions. I'm just briefly going to go over this. You can have different types of data. So you can have numeric data, you can have categorical data, and essentially in your numeric data you can have continuous or discrete data. So let me think. Continuous is like what we have here. We have a sample of heights. You can't really have two people who are the exact same height, because obviously if you shrink it down to the really infinitesimal limit, they're probably out by so many nanometers or picometers or something, you know. That's continuous. Essentially, continuous means that you can't necessarily stick a number on it and have it be done. You can essentially have a large band of values, a large band of values that your data can have. But you can also have discrete. Discrete is just 1, 2, 3. It's your counting numbers, okay? It's the number of numbers on a die. It's the number of houses on a street. That's your discrete data type. So that's essentially all there is to numeric data in this lesson. Categorical data is essentially labels or groups. So labels or groups can be subdivided into two different types. You can have nominal data or you can have ordinal data. So nominal data is essentially like names, labels of things. So you can be male or female. You can be essentially married, unmarried. You can have a certain eye color. You can come from a certain country. Okay, these are things that just don't really have any inherent value to them. They're just labels, essentially. They don't have a hard hierarchy of values. Whereas ordinal data, hierarchy of values, you can also say that they're ordered. Ordinal data is ordered, and it essentially is a category that has a meaningful order to it. So you can have somebody who has a certain level of education, as I've written here, or you can have a customer satisfaction rating. So you can have a customer satisfaction rating between 0 to 5, whether or not they like the service that was given to them in the shop. You can have like the personality tests that are out there, like the Myers-Briggs personality test. I think it's the Myers-Briggs. I think it's what you call it. But it's like the 4 letters you get. You get like INTP, whatever, whatever there is. I'm an INTP, that's why I said that, because that's the only one I remember. But in those personality tests, you can have like an order of your answer. So you can like say the question would be something like, I work well in groups, I enjoy being the center of attention, and then you say, I strongly agree, I strongly disagree, and then you somewhat agree, somewhat disagree, and you're completely neutral. So there's like 5 values there you can fall into, and there's sort of like an order to them. So that's ordinal data. That's the two different types of data. In the 2 different types of data, you can have sub-data from that. That's all you need to know at the moment. So recognizing the types of data are essential. Essentially, they are essential, and it determines which statistical methods are valid as well. So it's really important to understand something like the different types of data. But if you really break it down, it's really only those 4 things at the moment. We do get a lot deeper into this course. We get more involved in things whenever let me see, the questions beg of us to do so. So those are essentially your definitions. That's the wordy gobbledygook stuff that you do really need to understand, but it's probably not why you like statistics. It's not why you want to get into the job. It's because you are a numbers person. You're a numbers person. You like facts and figures and things like that. So we're going to go into a little bit of that, starting with the mean, because the mean is the average. Everybody knows what the average is. Everybody talks about the average, the mediocre, the mean, the you know. Everybody sort of understands what it is, and there's a formula here for it. You basically take the sum. I have this data set, as I say, of heights, and you basically take the sum of heights and you divide it by the number of heights that there are. So yeah, that's essentially what the mean is. I don't think I need to go too much more in depth than that, but there you go. You can either do it through NumPy or you can do it just manually. Obviously you're going to use NumPy because these 3 things here at the top are extremely important. You'll be using them every day, and they're really handy, and it means that you don't have to do stuff like this when you're manually calculating out these formulas. These mathematical formulas can get really dense and really heavy, and somebody out there has already wrote those formulas into a package, so just use it because you'd be wasting time otherwise. Obviously, challenge yourself to think about how you would come up with these, like little lines of code and stuff like that. At the moment it's not too difficult, but when it does start to get a little bit difficult, it can help you gain an intuition for how things work, because it makes you question every single term that's being put into the formula, and that's really important whenever you're trying to garner a really deep, insightful intuition into this sort of stuff. So for now, I'm going to assume you know how to calculate the mean. Everybody knows how to calculate the mean, let's be honest. And it's the average. You understand, in the distribution, it's where the center of your data sort of lies. It's where everybody sort of congregates. That's what the mean is. I'm going to stop talking about it because it is interesting. It is interesting, but it's, elementary, dear Watson. And so the median is a little bit more, how would you say it? It's a little bit more indicative of your data. So say if you have multiple billionaires in your country, okay? The billionaires, the outliers, are going to skew the mean. They're going to skew the average. They're basically going to make it look as if, oh, well, there's a whole load of billionaires in here, so on average there's probably some millionaires in that place, when really that's not the case. What you want to find in cases like that, when you have outliers, you want the median, because the median then is bang straight in the middle of your data, okay? Your data set is nearly the same as the mean whenever it's normally distributed. Whenever your mean and mode are practically identical, you basically have like a symmetric data set. But in cases where you got a little bit of skew, there's a little bit of inequality going on there, like the wealth inequality going on in in the Western countries and stuff like that. You need to rely on the median, because the median is not it's more robust when outliers are present, as I've said here. The mode is often useful for the categorical data. So the categorical data, remember I was talking about, is the labels, and within the 2 subtypes of the categorical data, you have the nominal data and the ordinal data. The mode is really important when it comes to that, because it basically lets you know, it's another summary. It's another thing that lets you talk about your data, okay? You can turn around and say, well, the billionaires tend to be single. The billionaires tend to have brown hair. The billionaires tend to have blue hair. Whatever, I'm talking about billionaires and stuff, but it doesn't matter. It's another way to talk about your data, and that's really important when you're trying to communicate exactly what you're saying to people. That's why statistics is so prevalent in business. It's because it lets the maths nerds and the maths junkies talk to other normal people. That's why they have so many statistics people, okay? So you need to have somebody who really understands the mathematics, but you need to further understand how to communicate that to other people. That's kind of why I'm doing this. I hope I'm doing a good job. Probably not. But we move on. Standard deviation tells you exactly how far away your data is. I don't know if that's inverted in the recording or not. Let me double check. Nope, it's perfect. Okay. What have I got here? Standard deviation is really important. This is a bell curve. Bell curves, you've seen bell curves before. A really cool real life demonstration of a bell curve is called the Galton board. He was a polymath and originator. Galton board. There it is, the Galton board. I kind of want one of these now that I've googled this, because I think it would actually be fantastic. I'm holding up a normal distribution next to my head and I'm googling a Galton board because that's what we do here, you know. You can't actually see it, I just realized, because I have the recording stuck. But basically a Galton board is like this. I will show you. Hold on. Don't worry, you're not going to miss out. Okay, maybe you are, because I can't figure it out right now. But anyway, point being is that a Galton board is essentially you've got the balls, you've got a board, you flip the board, and then the balls fall into the grooves, and they fall into the grooves in such a way that it looks like this. Okay, Google the Galton board. 68% of your data is going to fall within one standard deviation of your normal distribution. 95% of your data is going to fall within 2 standard deviations of your data, and then 99.7% is going to fall within 3 standard deviations of your data. So anybody that is outside the 3 standard deviations of data is an outlier. A serious outlier because they only comprise 0.3% of the data. Outliers we'll get a little bit into, but that's what standard deviation does. It tells you how far away a certain data point is away from the mean. That's essentially what it is. That's exactly what I've got here. That's the variance, because we square it for a particular reason. I guess I could get rid of this square and then see what happens, but actually, you know what, I'll let you do that. I'll let you play around with this little bit of code, or think about it yourself. What would happen if I got rid of this square? Why is the square there? Also, the specific definition of this thing is called the variance. If you take the data and how far away it is from the mean, you have to square it. If you take the data and how far away it is from the mean, and you square it, that gets you the variance. And then you square root that gets you the standard deviation. Okay? The standard deviation tells you how far away you are from the mean, from the center of your data. If you're really far away, you're an outlier. Okay? That's essentially it. That's essentially all there is to the standard deviation. Take a look at this code. Try to code it yourself. Look it up and stuff. You know what I mean? You can do that. There's another lesser known deviation, which, to be honest, I've used very rarely. I can't even think of a single time that I've ever used this, but it is important because it's not as influenced by outliers, and essentially it's the same thing, except you're taking the absolute value. So that's a little hint as to why there's a square here. The absolute value basically means that you can't, anything within an absolute value function isn't negative, so it has to be positive. As again, that gives you a hint as to why this is squared. Mean absolute deviation isn't as influenced by outliers, and that's why it's used sometimes. So if you really wanted to gather information on the population's wealth, you'd probably use something like this to mitigate the influence of the billionaires, because we don't want mega billionaires. But yeah, a standard deviation tells you how far away you are from the mean. That's really all you need to know at the moment. The mathematical formula here, this and this, I'll not go too deep into it. What I'll do is essentially show you this code. If you know how to code, you know what it is, but you don't know what the maths is. If you know what the maths is and you don't know the code, you can look at the code. And I think what you should do is you can confer in the comments below. If there's something here you don't understand, whether it be the maths or the code, I think you should come together in the comments and figure that sort of stuff out between yourselves. Because that's also another thing, you're practicing communicating with somebody else by doing that. And that's really important. Another way to measure your data is using what's called the interquartile range. This is something that I remember doing whenever I was like 16 and didn't really care all too much, but like same time it's pretty cool. It's what's used in box plots. If you've never seen a box plot, it's essentially a rectangle where you've got your Q1 at one end, your Q3 at the other end. Q2 is exactly the same as the median of your data. So if you did want a quick way to calculate your median, you can use this. It's exactly the same as this in NumPy. So yeah, quartiles are essentially like the proportion of data that's below that point. So this is the first quartile. So everything up to this height is where about a quarter of the data lies, and then half of the data lies on either end of this point, which is 172, and then about 3/4 of the data is comprised of every height that is less than or equal to this value. So that's exactly what the quartile range is. Quartile range gives you the range of your data. You want to talk about it's between this and that, you're talking about the interquartile range. It's between this and that, it's the interquartile range. Okay, outliers for the interquartile range are these two formulae. These two formulae, I'm going to let you write that out in code yourselves, just to figure out exactly how would I figure out if this data point is an outlier or not. I can do it through an interquartile range, or as I showed earlier, you can do it through the standard deviation. You can look at your standard deviation, add 3 standard deviations from your mean, and see any data points that are after that or below that if you're going to go the other way. Whatever the way the camera's facing me, it's all mirrored. But anyway, that's how you find an outlier. You can do it through an interquartile range, or you can do it through the standard deviation, or you can do it through the mean absolute deviation. So that's how you find outliers. Outliers are really important. Fraud detection is like #1 thing that outliers are used for, because it's really important to know if somebody's card is being used and finances are being used illegally. So yeah. So I'm going to leave the outliers for the interquartile range as a little bit of a homework for yourself, but there is also homework Jupyter notebooks in the description below. If you go to those notebooks, you'll be able to practice a little bit of the stuff that I've taught here, but a lot more. It goes a lot more in depth in the Jupyter notebooks, because it lets you think. You might have already known all this stuff, to be honest. Let's be honest, you clicked on this video because you want to be a data scientist. You want to be able to implement your code and your maths knowledge into the world. So you wanted to see exactly what I had to offer. I think this isn't really enough for you. I think for you, you need to go onto the Jupyter notebooks and write some code yourself. In there, I've put in like a random sample. Forget like the second cell. The second cell is like a randomly generated I think it's heights as well, I can't really remember at this point. It's randomly generated. You play about with that data set using the summary statistics and the measures of spread as well. Use that. It'll solidify your knowledge quite a bit. So yeah. So to recap, we went over descriptive versus inferential statistics. The descriptive statistics is essentially your summary statistics. This tells you everything about your data set. This highlights everything you need to pay attention to. And then the inferential statistics is essentially where you take a sample from a population and then you do your summary statistics on that to make inferences on the population. We also went over different data types. We went over the numeric and the categorical data types. In your numeric, you can have either discrete data types or continuous data types. And in your categorical, you can either have nominal, which is essentially your labels that aren't ordered in any way, or you can have your ordinal. Exactly. I was waiting for you to answer, of course, because I didn't blank at all there. Your ordinal subtypes. So your ordinal subtypes are essentially ordered labels of things. Strongly agree, strongly disagree. Think of that band for the personality test. And then you've also got your measures of center. Your measures of center consist of your mean, mode, and the median. We went over that thoroughly, I think. And then you've also got your measures of spread, which is your standard deviation, and your mean absolute deviation, as well as your quartiles. All of that is essentially the building blocks of your data science journey. And you need to understand all of that very thoroughly if you want to get anywhere near the fancy machine learning stuff. So I hope you found this video very helpful. If you have any questions, or if you think there's anything that needs a little bit of reconsolidating, or you're confused, please write a comment down below, because if you write comments, I'll be fit to see. It's constant, it'll be instant, immediate feedback from me if I'm doing a good job explaining any of this stuff. If I'm not, if there's somewhere where you're lost, I will hopefully remake the video, edit it, and make sure that it all ties nicely together. And yeah, make sure to have discussions in the comments as well, because the best way to learn is essentially trying to explain it to somebody else. And if you've got somebody else to learn with, then you'll be able to learn a lot faster. I hope you enjoyed this video. Make sure to check out the Jupyter notebooks and like and subscribe. Make sure to be here for the rest of the videos, because this is only getting our toes dipped in the water. You want to see more. I know you do. Just wait. Wait a couple of days and I'll have another one ready for you. Bye bye.